no doubt, whenever you are becoming as an electrical contractor, it is an you can say the great experience. So those who are thinking to do the work of the different projects, so they can think of this particular tender, and they can try to read these quantities, what are the nature of work are available inside their town or inside their, you can say, municipal corporation. Yes, and because of this nature of work, we are having the you can say there can be a different light system is available, different you can say transmission system is available, underground system, overhead transmission system. Yes, and I my appeal is to you that you have to read these tender notices which is available in the newspaper. Yes, so that you will get some information related to this electrical contractor field. Okay, we are interested for the numericals. Yes, and in the last class we have seen the two numericals, and that two numericals are asked in the exam already. Yes, today we are interested for more two numericals, so that you will get some confidence, and if the question will be asked for you for 7 to 8 marks to find out the size of cable for the electrical motor, or you can say for the transmission line, or you can say for the wiring, then you have to solve in this way. Okay, so we will take the numerical first. We will read the numerical together, so that you will get some confidence. Okay, I hope my screen and my voice is audible to you. Okay, so if you are persisting any problem, then you can unmute yourself and you can speak. Yes. So this is the example which is already asked in the university exam, and the numerical says that 10 HP, that is a 10 horsepower, three-phase squirrel cage induction motor. That we know that the induction motor has two types: squirrel cage and you can say slip ring. So we are using this in this numerical squirrel cage induction motor of continuous rating using star delta starting is connected through 400 volt. We know that whenever we are considering the three-phase supply, we have to correct the value as 400 volt or sometimes 440 volt. Okay, supply by three single core PVC cables run in conduit. So that is the you can say the wiring is available from 250 feet. So they have given the dimension of the length 250 feet in terms of meter. Also they have converted this value 76.2 meter away from multi-way distribution fuse board. After that they have given its full load current is 19 ampere. Obviously the three-phase current is available. That is the value 19 ampere is available. Average summer temperature in electrical installation wiring is 35 degrees Celsius, and they have given the value in terms of Fahrenheit also. Calculate the size of cable of motor, as we are interested to find out the size of cable. Here we are interested to find out for the case of motor, and they have given consider the maximum allowable voltage drop is 2.5%. In the last numerical, this consider maximum allowable voltage drop is not given, but still for the sake of electrical installation, we have to consider this value is a constant, and that is a 2.5%. Yes. Now, by reading this numerical, try to write the given quantities. Okay. So, what are the given quantities? First quantity is the motor load. Obviously, they have given the value in terms of horsepower. We have to convert in terms of watt. And what is the equation, or what is the formula to change horsepower into watt? So, 1 horsepower is nothing but 746 watt. So we have to multiply with this 10 with 746. So it comes as 7460 watt. After that, they have asked us that the three-phase supply system is available. So we have to consider the supply voltage as 400 volt. The length of cable is 250 feet. So we have to take the quantity as 76.2 meter. Motor full load current they have given. So we are not interested to find out this value. we can find out this value in terms of this P divided by this V. You will get near about this value, 19 ampere. The temperature factor they have given for 35 degrees Celsius, and by looking at the table, the factor value is 97.97. Yes, we will show you this table particularly, and they have given maximum allowable voltage drop 2.5 meter. And what they ask the size of cable which is used for particularly motor. Yes, so this is the quantity which we are interested to find out, and our intention is estimation and costing, and under this we are taking this numerical practice. Okay, now obviously if they are giving the numerical, they are going to provide the data. So the data says the first data is related to the temperature factor. Yes, and they have given various temperature range in terms of Fahrenheit, degree Celsius and Kelvin. We are interested for 35 degrees Celsius, so we have to consider the factor as 0.97. Yes, so that we have given, or we can conclude that we have to use this factor as 0.97. Yes, after that they have given the cable size, current rating with voltage drop. They have given the voltage drop indication, so we have to use this table. So what this table indicates? This table indicates single phase AC or DC and three phase 3 or 4 core cables. So if you are interested to find out for single phase, but our application is 3-phase induction motor, so we will look this table directly. So they have given the current rating and volt drop per 100 feet, and they have asked for 250 feet. Okay, sorry, 250 feet they have asked, and corresponding number and diameter of wire in terms of inch and cross section area in terms of inch square they have given. Yes, now we will go ahead. Now we can select the size of cable for full load current of 19 ampere. Yes, so that they have given directly the full load current is 19 ampere. So what is our aim? Our aim is to find out the most suitable size of conductor or the cable which is suitable for this full load current. So by looking at table, we have to find out 19 ampere. 19 ampere is not available in this table. We can consider the maximum, we can say upper limit. So we have to consider this 23. So 23 current rating for this corresponding value of voltage drop is 5.3 that we have to consider, and number and diameter of wire in terms of inch is 7 by 0.036, and the maximum area, you can say cross section, is 0.007 inch square. Yes, now here we have to consider this value 7 divided by 0.036, but our numerical is not over yet. Why? Because they have given to find out 250 feet. We have to find out the voltage drop for 250 feet. Yes, so here you can see I have made the conclusion as for the 23 ampere we can select the area, or you can say the size of conductor is 7 by 0.36 inch. So this is the symbol of inch. Yes, instead of writing the word inch, we can use this symbol. But we have to remember that this is a 3-phase system, that is 3-core cable, and the voltage drop is 5.3 for 100 feet. That is the corresponding voltage drop. This is 5.3. Okay. Now we have to find out for it means we can use 7 divided by 0.036 cable according to the table 4. Yes, so that can be our rough conclusion, but we have to check the selected cable for the temperature factor. Yes, because the temperature factor is 0.97. Yes, and at 35 degrees Celsius, then what we are going to do? We are going to multiply this 0.97 with this 23 ampere, which is the maximum amount of current. The value becomes 22.31, and as our current rating is 22.31, which is not available in the table, so we are going to consider the same amount of current, that is called the 23. So that is okay. Yes, so here I have made the conclusion as, since the calculated current value 22.31 at 35 degrees Celsius is less than that of current carrying conductor of 7 divided by 0.036 cable, which is 23 ampere. Therefore, this size, which size? 7 divided by 0.036 inch. Yes, is also suitable with respect to temperature. आतापर्यंत आपण बघितलं की with the help of current and temperature, we have found out that the value of 7 divided by 0.036 inch is suitable. Yes. Now we will go ahead. What is the next term? The voltage drop they have given. Yes. For the 250 feet, we have to find out. Yes. For the 100 feet, they have given as 5.3. So one can say for 100 feet, it comes as 5.3 value. Yes. So this is the 5.3 value they have given, and we are interested to find out for 250 feet. Yes. So we have to multiply this term with 250. Yes, 250 into 5.3 divided by 100. Yes. So these are the calculations in terms of related to our particularly actual voltage drop, and we have not forget to multiply with the actual current, rated current 19, and divided by maximum current, that is 23, because to find out the voltage drop we have to use this value of current also. Yes, so that is a factor which is available to this side. Okay, and after this we will get the value 10.94 volt. Yes, and we have to consider the maximum allowable voltage drop 2.5%. So 2.5% into 400 volt, so that comes as 10 volt. Now which value is maximum? Obviously 10.94 value is greater than our maximum allowable voltage drop. Therefore this is not a suitable size of cable for that given load. Now what we are going to do? So we will select the next size of selected cable, 7 divided by 0.036, which is, what is the next value for 7 divided by 0.036? It comes as 7 divided by 0.044. Yes, so that is the next value, because our maximum allowable voltage drop is less in this case than actual voltage drop. So we have to go ahead, find voltage drop again. Yes, so we have to find out the voltage drop again. According to the table 4, the current rating of 7 divided by 0.044 volt, inch is 28 ampere, and volt drop in per 100 feet is 4.1 volt. So what is the corresponding value of this? 4.1 volt. Yes, that we have to consider. Now we have to find out for again the actual voltage drop. So how to find out the actual voltage drop? The formula is very simple. Consider for 100 feet the value comes as 4.1. Yes. Now we have to find out for 250 feet. Now what is the value of 250 feet? We have to find out. So 250 into 4.1 divided by 100. Now we have to multiply with this term with our current rating. What is the current rating? Current rating is 19, that is the full load current, divided by 23. Yes, which is the maximum value of allowable current. Yes, and after this we have to consider the value as 8.46. Now this value is less than our maximum allowable voltage drop. तुम्हाला कळत असेल आता की मॅक्सिमम अलाउएबल व्होल्टेज ड्रॉप याचा अर्थ असा की तो व्होल्टेज ड्रॉप तिथे परमिटेबल आहे किंवा तो तिथे ऍक्सेप्टेबल आहे. येस, हाऊ मच? अँड दॅट कम्स ॲज 10 व्होल्ट. नाउ दिस व्हॅल्यू इज लेस than this. Yes, so the actual voltage drop is less than that of the maximum allowable voltage drop. So this size is most appropriate. That is our conclusion, and suitable cable size for electrical wiring installation of given situation. So that is our conclusion. Yes, now I hope you understood this numerical. या न्यूमेरिकल मध्ये थोडा ट्विस्ट केलेला आहे आपण. Yes, why? Because as we know that whenever we are taking the different numerical practice, then and then only our confidence is going to increase. जर मी सिंपल न्यूमेरिकल घेतले तर तुमचा कॉन्फिडन्स वाढेल, पण परीक्षेला सिंपल न्यूमेरिकल येणार नाही. परीक्षेला जे न्यूमेरिकल्स येतील ते थोडे डिफिकल्ट लेवलचे असतील, बिकॉज फ्रॉम धिस EIMT सब्जेक्ट ओनली द numericals from unit number 1 and unit number 5 are going to ask. Yes, and believe me, if you are going to solve the numericals and derivations, you are going to score maximum. Yes, we don't know how the exam are going to happen for your batch. Yes, but still we are practicing the conventional. Yes, so that you will try to score the good marks in this subject. Yes. Now I will try to repeat this numerical in a fast way, so that we will take one more numerical and we will conclude with our today's session. Okay. So what is the numerical? I'm repeating again. Yes. So those who have missed this numerical or they are not understanding any concept, I will try to explain in a better way. Yes. And still, if you are having any doubt, then you can text me. Okay. So what is the numerical? The numerical is very simple. The numerical says that we have to find out the cable size for the cable for the motor. Yes. So they have given the motor specification. What is the motor specification? The load they have given, motor load. What is the motor load? 10 horsepower is the motor load, and it is connected to 400 volt. So that is the voltage. Yes. And they have given that we are going to connect this PVC cable run in conduit from 250 feet. Yes, away from multi-way distribution fuse board. तो जी मोटर आहे ती फ्यूज बोर्ड पासून ते तुमच्या ऍप्लिकेशन पर्यंत हे अंतर किती तुमचं 250 फीटचं अंतर आहे. Yes, and they have given directly full load current is 19 ampere. If they have not given this value, then again there is one more equation which is available, and that is the P divided by V, and in terms of this you can find out the current value. The average summer temperature in electrical installation is 35 degrees Celsius. So we have to find out the cable size, but they have given maximum allowable voltage drop is 2.5%. Yes. Now try to write the given quantities. 10 horsepower, 10 into 746, that is 7460. 400 volt is the supply voltage. Length of cable is 250 feet. Maximum, you can say motor full load current is 19 ampere. And for the temperature factor 35 degrees Celsius, they have given the value 0.97. But this value is from the table. And maximum allowable voltage drop is 2.5%. Okay. Now we will see the table. So this is the table they must have given to you, and because of this table you can solve this numerical. Yes, as we know that they have given the value of 19 ampere current. So 19 ampere is not available in this table. Obviously directly 18, from the 18 they have given the directly 23 ampere reading. Yes, so we have to select this maximum current. So 23 correspond to 5.3 per 100 feet, and the allowable, you can say the diameter is 7 divided by 0.036. Yes, if they are going to ask you the area, then you can write this area in terms of inch square, and that is a value 0.007. Yes, but our numerical is not over yet, because we have to consider the voltage drop. Yes, so for this we can select the size for 7 divided by 0.36 inch for the 23 amperes. Yes, and we know that for the 35 degrees Celsius the factor is 0.97. So we have to multiply this 0.97 with maximum current, that is 23. Our value becomes 22.31. This value is less than our this value, so that is the suitable. Yes. So here I have made the conclusion. It is less than that of the current value, which is 23 ampere. Therefore, the size is also suitable with respect to temperature. But we have to take the actual voltage drop. What is the formula? The formula is very simple. What is the formula? Formula says that they have given the value for 100 feet. 100 feet, they have given the value as 5.3 volt. Yes. And what we have to find out? We have to find out for 250 feet. He method तुम्हाला कदाचित माहिती असेल. Yes. A quantity दिली असेल with respect to B. C quantity they are going to ask with respect to D. So we have to multiply this 250 into 5.3 divided by 100. So that is can be our equation. But we have not to forget to multiply with our actual current they have given and maximum amount of current that is allowable. That is 23 is allowable. Yes. Solve this equation. We will get this value 10.94. After this maximum allowable voltage drop. So obviously maximum allowable voltage drop we are going to corresponding with our supply voltage 400 volt, that is 2.5%. 2.5% दिला आहे आणि 2.5% जर तुम्ही consider केला 400 volt चा तो येईल तुझा 10 volt. Now comparing this value is more, which is not acceptable. This value is acceptable because this term indicates the maximum. Yes, it is not a maximum, it is actual. Yes. आणि तुम्हाला कळत असेल आता की ज्यावेळेस आपण एखादी गोष्ट मॅक्सिमम म्हणत असतो त्यावेळेस ती दोघांपेक्षा ही मॅक्सिमम व्हॅल्यू पाहिजे. जर ती येत नसेल तर आपल्याला काय करावं लागेल, त्याच्या पुढचे साईज आपल्याला सिलेक्ट करावं लागेल यापेक्षा. येस, here the actual voltage drop is greater than that of the maximum allowable voltage drop, therefore it is not a suitable size that we have to mention here. Now what we are going to do, we are going to take the next reading for this value, and that comes as 7 divided by 0.044. Now this corresponds to 28 ampere, and now we have to solve for 28 ampere this value. Yes, now this comes as 100 feet. They have given the value as 4.1. Now we have to find out for 250 feet. So same 100, 250 into 4.1 divided by 100. Yes, and we don't forget to mention the amount of current which is available inside the numerical, that is 19, and divided by 23, which is the maximum allowable current. Yes, and it comes as 8.46. Now this value is minimum than our maximum value of voltage 10 volt. So this is the most suitable size, or you can say most appropriate size of the electrical wiring installation for given situation. Yes, I hope you understood this concept clearly. Yes, if you have any doubt, then you can contact me at any time. Yes, we will try to use the residential numericals. Yes, so here we are interested to find out the estimation for residential building wiring. Yes, now what we have to do here, we have to estimate the quantity of materials required with specification. Yes, let's say this is a numerical which is asked in the university exam, and they have made the chart inside with respect to this numerical. What is the numerical? A residential single bedroom flat is to be electrified with our PVC concealed type wiring. Yes, estimate the quantity of materials required with specification. The details of fittings are as follows. आपल्याला एक फिटिंग करायची आहे एका सिंगल बेडरूम फ्लॅट मध्ये, आणि आपल्याला एस्टिमेट करायचे क्वांटिटी ऑफ मटेरियल किती लागेल त्या स्पेसिफिकेशन साठी. येस, so serial number is available, name of the room is available, size dimension of that particular room is available, number of tube light points, number of ceiling fans, number of ordinary lamps, and number of plug points they have given. Yes, so inside the hall, 2 light points, 1 ceiling fan, 2 ordinary lamps, and 2 plug points are available. For the bedroom, 1 tube light, 1 ceiling fan, 1 ordinary lamp, and 1 plug point is available. For the kitchen, again, number of tube light is 1, number of ceiling fan is 1, number of ordinary lamp is 1, and number of plug is 1. For the bathroom, we don't need the tube light, no, we don't need the ceiling fan, we need the ordinary lamp, and we need the plug point. And for the toilet, we don't need the tube light, we don't need the ceiling fan, we need the ordinary lamp, and we don't need the number of plug point for the toilet. Okay, because we cannot make this here as 1. Yes, because they have made this as dash. Yes, so according to the numerical, we have to solve this, you can say the example. Okay, now they have made one condition: assume necessary data as per Indian electricity rules and mention them clearly. Yes, so they have asked, or they have instructed us, we have to use the Indian electricity rules. Okay, now this can be a step number 1. So plan of building, we have to draw the plan of building. Obviously, beside the hall, the bedroom and kitchen is available. The bathroom, or you can say in toilet, the dimensions they have given. Yes, and this is the space that is called as the door space. Yes, so one can enter from this particular side. Yes, he can enter inside the bedroom also, he can enter inside the kitchen also, and he can use the bathrooms and toilets from this particular hall. Yes, so we have to draw the plan also. Yes, because see, if you are solving with systematic way, then you will surely get the full marks. Yes, if you are skipping the steps, then you will lose the marks. What is the step number 2? We have to use the fittings, details of fittings. Yes, So this is the main distribution box MDB. Yes, this is the, you can say, the tube light is available according to the specification. This arrangement we have to make. So fan is available, F1, F2, and F3. Three fans are available, and order lamps are L1, L2, L3 is here, L4 is here, L5, and L6. Yes, and the tube lights TL1, TL2. Obviously, the hall needs the two tube lights. The TL3 inside our, you can say, the bedroom, and TL4 inside our kitchen. Yes, we need the switchboards. Yes, switchboard 1, switchboard 2, switchboard 3, switchboard 4 here, switchboard 5, and switchboard 6. Yes, so these are the, you can say, details of PT. Now, this is the actual planning the electrical contractors have to draw, because they have to submit this proposal for the verification, or you can say for the sanction purpose, so that after this sanction purpose or verification, they are going to do the actual fitting. Yes. Now the total load we have to assume. Yes, because they are not given actually the wattage rating. Yes, we have to assume for the fan. Let's say this fan can be of 60 watt. The light point, the light uses the 60 watt. The tube light uses the 40 watt, and the plug uses the 100 watt. So according to the total load, we have to make the addition of these total quantities, and that comes as 1200 watt. So fan are there of the quantity 3, so we have to multiply this 3 with our 60, so it comes as 180. The light load, the 6 quantity are available, and we have to multiply this 6 with 60, so it comes as 360. Tube light are 4, yes, and we have to multiply this 4 with 40. Yes, not given this wattage rating. Depending on the assumption, we are using this wattage rating for this particular load. Yes, but if they have given this wattage rating, then that we have to carry here, and we have to solve according to this. Yes. So, and for the plug point, so 5 plug points are available. Yes, and 5 we have to multiply with 100, it comes as 500. So 500 plus 160 plus 360 plus 180, it comes as 1200 watt. Now what we have to do? We have to find out the number of sub circuits. Yes. Now let's say power per circuit is 800 watt or 10 points. Yes. तुम्हाला कळत असेल आता की आपल्या घरामध्ये सब सर्किट हे आपल्याला तयार करावं लागतात. येस. सो सब सर्किट आपण कशी तयार करू? सो 800 वॅट साठी एक सब सर्किट असेल असं आपण कन्सिडर करू, आणि आपला टोटल लोड किती आला आहे? 1200 वॅट. So we have to multiply this 1200 divided by 800. Obviously, this is not 1, so it comes as 2. So we need the subcircuit 1 and subcircuit 2. So we have to divide this load. Yes. So how we have to divide this load? I'm taking hall, bathroom, and toilet in subcircuit 1. Yes, and bedroom and kitchen in subcircuit 2. तुम्ही combination change पण करू शकता, but make sure that the division of this 1200 must be equal. Somewhat equal. Yes, आणि जर तुम्ही इक्वल केलं तर एका ठिकाणी 680 येईल आणि एका ठिकाणी किती येईल? 520 येईल. Yes. Now what we have to do? We have to calculate the current. आपण आता कॅल्क्युलेट करायचं आहे कशाला? करंटला. सब सर्किट 1 साठी आणि सब सर्किट 2 साठी. Obviously the formula is very simple. P divided by V is a formula to find out the value of current which is used for particular amount of current. Yes. So the power rating that we have to calculate already. So 680 divided by 230, which comes as 2.95 amperes. For the subcircuit 2, P divided by V, that is 520 divided by 240, it comes as 2.26 ampere. Yes. Now here, for the purpose of we are doing the installation of wiring, so we have to use the factor as maximum current. Yes. So 2.5 times maximum current can be available. So 2.5, because these are the Indian electricity rules. Yes, we have to consider the extra current that can be available inside the future, that we have to consider. So 2.5 into 2.95 and 2.5 into 2.26, it comes as 7.3 and it comes as 5.65. Yes. Now we have to check this value according to the table, and we have to write the conductor size available. Yes. So from the table, if we are observing the table carefully, so the wire can be carried. Sorry. Okay. So here we can see the current rating of copper conductor between 3-core and 4-core cables via IR, PVC, or polyethylene insulated and sheeted with through rubber, PVC, or lead. Yes. And what is the value? The value is the maximum current is 10. Yes. And the number and diameter of wire is 3 divided by 0.737, and the nominal area is 1.5 millimeter square. So here it is not in inch, it is in terms of millimeter. Yes. And why we have taken this value as 10? Because if we are considering for 1.5 millimeter square, the value comes as 3 divided by 0.737. VIR insulated copper conductor wire may be selected. Yes. And the wire can be carried a maximum current of 10 ampere. Yes. So this is the numerical that we are interested to find out. Yes. So if we are taking the practice of such numerical, then it is it increases the confidence, and we can solve this numericals in exam clearly. Yes. And the numerical is very simple, and I hope you understood this numerical. And here I have made the circuit which uses the dimensions. जर आपण डायमेन्शन्स यूज केले होते त्याला जर आपण स्प्लिट केलं सो प्रॉपरली आपल्याला तिथे लाईट फिटिंग ही करता येईल. येस. ऍक्च्युली हे रेसिडेन्शियल बिल्डिंगचा प्लॅन असल्यामुळे किंवा तुमच्या टॉपिक मध्ये असं म्हटले त्यांनी की रेसिडेन्शियल बिल्डिंगचे न्यूमेरिकल्स आणि कमर्शियल बिल्डिंगचे न्यूमेरिकल्स हे विचारणं गरजेचं आहे. being an estimation and costing unit are going to consider. आपण जे प्रिव्हियस जे न्यूमेरिकल्स बघितले ते बऱ्यापैकी तुमचे कमर्शियल न्यूमेरिकल्स होते, ज्यामध्ये आपल्याला इंडस्ट्रियल मोटर्स असेल किंवा इंडक्शन मोटर असेल ते आपण त्या फिट केल्या होत्या त्या ठिकाणी. आणि टुडे वी हॅव सीन द रेसिडेन्शियल न्यूमेरिकल प्रॅक्टिस.